So in this video, we're going to learn the concept of Euclid's division lemma. So out of these three words, which one do we recognize? We recognize the word division. So previously we studied division. We first saw that division is repeated subtraction, and then we learned the long division method. So I'll once again do the long division method. Let me take a very simple example, 20 divided by 6. So let's say we have 20 divided by 6, right? So I'll do it by the long division method. So 20 divided by 6. So 6 goes in 20 3 times. 3 multiplied by 6, 18. 20 minus 18 is 2. Any more digits left? No. So we say that 20 divided by 6 is equal to 3 remainder 2. So 3 remainder 2. Right? Next, we learn the four terms: dividend, divisor, quotient, and remainder. So what is a dividend? The number which you are dividing, in this case 20, is your dividend. The number by which you are dividing, in this case 6, is your divisor. Next, this over here is the quotient, this over here is the remainder. So this over here is the remainder, and this over here is the quotient. Next, we saw the relationship between these four things. What is the relationship? Simple. 20 is equal to 6 multiplied by 3 plus 2, right? That is, we saw that dividend is equal to divisor multiplied by quotient. That is, what is 3 over here? Multiplied by quotient plus remainder. So plus what is 2? It is the remainder. So this is just a recap of what we learned, right? So basically dividend is equal to divisor into quotient plus remainder. So this over here is Euclid's division lemma. I repeat, basically our long division method is basically your Euclid's division lemma, right? So someone asks you what is Euclid's division lemma? It is simply the long division process. That is, whenever we divide two numbers, then dividend is divisor into quotient plus remainder. So how we state Euclid's division lemma is, instead of taking dividend and divisor, we take them as A and B. So instead of taking it as 20 and 60, so what I'm going to do is, I'm first going to rewrite this again over here. So 20 is equal to 6 into 3 plus 2. So I'll take 20 as the number A, and I'll take the divisor as the number B. Clear? So we have A is equal to B multiplied by, what is 3 over here? It is the quotient. So what is the first letter of quotient? Q. So I'll put a small q over here, plus what is 2? It is the remainder. First letter of remainder, R. So R. So what do we get? A is equal to B into Q plus R. So what Euclid's division lemma basically states, whenever I have two numbers A and B, such that we do A divided by B. I repeat, whenever we have two numbers A and B, such that we do A divided by B, like over here, what are the numbers? 20 and 6. So when we do A divided by B, we can rewrite this as A is equal to B into Q plus R. So dividend is equal to divisor into quotient plus remainder. I did the same thing. Instead of dividend and divisor, I took it as A and B. So whenever we have two numbers A and B, A is equal to B into Q plus R. So this over here is your Euclid's division lemma. So short form Euclid's division lemma. Now the important thing over here is, what is R? See, your remainder will either be 0, right? So it is either 0 or it is greater than that. Now what is the maximum value of the remainder? It should always be less than the divisor, right? So it is less than B. A very important thing, right? So for any two numbers A and B, A is equal to B into Q plus R, where the remainder is always between 0 and the divisor, right? See, like over here, 20 divided by 6, remainder is more than 0 but less than 6. So your remainder will always be less than the divisor. Let me take a few examples to explain this. Let's say I have 3 divided by 2. It is equal to 1, remainder 1. Next, 4 divided by 2. It is 2, remainder 0. Then I have 5 divided by 2. It is 2, remainder 1. Right? Then I take 6 divided by 2. It is 3, remainder 0. So whenever, what is the divisor over here? It is 2. What is the remainder? Either 0 or 1. So the remainder will either be 0 or less than your divisor. Let me take more examples. Let's say I have 4 divided by 4. It is 1, remainder 0. Next, 5 divided by 4, 1, remainder 1. Then 6 divided by 4, 1, remainder 2. 7 divided by 4, 1, remainder 3. 8 divided by 4, 2, remainder 0. Right? So as you can see, what are the possible remainders when we divide by 4? 0, 1, 2, 3. So it is either 0 or it is more than 0 but less than the divisor. What is the divisor over here? By what we are dividing, that is 4. So remember, the remainder will always be between 0 and b. That it will either be greater than or equal to 0 but less than the divisor b. As you can see over here, when divisor is 2, remainder is either 0 or 1. When divisor is 4, remainders are 0, 1, 2, 3. So it is greater than or equal to 0 but less than the divisor. So this is the concept of Euclid's division lemma. For any two numbers a and b, a is equal to b into q plus r, where the remainder is greater than or equal to 0 or less than b. Right? So now, how do we represent any two numbers in this relation? Let's learn it in the next video. I hope the concept of Euclid's division lemma is clear. It is basically a long division process. That is, dividend is divisor into quotient plus remainder. This is what is Euclid's division lemma. So instead of dividend and divisor, we just put a and b, quotient is q, remainder is r. So for any two integers a and b, a is equal to b into q plus r, where a and b are the integers, q is the quotient, r is the remainder. Remainder is greater than or equal to 0 but always less than the divisor. As you can see over here, remainder is either greater than or equal to 0 or less than the divisor. So this is the concept of Euclid's division lemma. So previously we have shown the concept of Euclid's division lemma. So I've stated it formally over here. So see, let a and b be any two positive integers. Then there exist unique integers q and r such that a is equal to b into q plus r, where r is greater than or equal to 0 and less than b. So see, what are a and b? They're nothing but dividend and divisor. So dividend is equal to divisor multiplied by quotient plus remainder. And as we saw, the remainder is greater than or equal to 0 but less than the divisor. For example, if I take two integers 6 and 2, so 6 is equal to 2 into 3 plus 0. 20 and 6, 26 into 3 plus 2. 1243 and 7, 1243 is equal to 7 multiplied by 177 plus 4. So whenever these two positive integers are given to you, first one label it as a, second one label it as b. Right? Now how do you get q and r? Simply divide a by b. Whatever quotient you get, that is your q. Whatever remainder you get is r. So see, a is equal to b into q plus r. So this is basically Euclid's division lemma, which is basically the long division process. That is, dividend is equal to divisor into quotient plus remainder. Right? So now if I give you any pair of positive integers, for example 20 and 6, and I ask you write them using Euclid's division lemma. So see, given any two positive integers, first label the first integer as a and the second integer as b. See, in Euclid's division lemma means you have to write it like this. So there are four things: a, b, q and r. So what is a and b? First number is a, second number is b. So a and b are known to me. Now what is q? Divide a by b. Whatever quotient you get, that is your q. Whatever remainder you get is r. For example, 1243 divided by 7 is, quotient is 177, remainder is 4. 20 divided by 6, quotient is 3, remainder is 2. 6 divided by 2, quotient is 3, remainder is 0. So whenever I give you a pair of integers, that is positive integers, how will you write it using Euclid's division lemma? That means you have to write them like this. So first integer is a, second integer is b. Divide the two, whatever quotient you get is your q, remainder is r. So you have a, b, q and r, write them like this. Right? So in the upcoming videos, we'll practice a few examples on how to write a pair of integers using Euclid's division lemma. As of now, is the concept clear? That is, what is Euclid's division lemma? Long division process. Dividend is equal to divisor into quotient plus remainder, where the remainder is greater than or equal to 0 and less than the divisor. Right? As you can see over here. Right? So this is the concept of Euclid's division lemma. So now let's practice a few examples on Euclid's division lemma.